Basically, since time immemorial, we've been talking about nuclear energy. And the best example of nuclear energy that many people don't talk about is the solar energy. Basically, it's a form of radiation that comes from the nuclear fusion of hydrogen atoms, and they form helium. And that radiation comes to the Earth's surface. And in Kenya, we have the solar being exploited in terms of solar panels. And in some places we've had the concentrated solar power plants. And in Kenya we are endowed with a lot of sunlight, and that map illustrates the global horizontal irradiation of Kenya. And we realize that we have an annual irradiation which averages to about 6 kilowatt hours per meter squared per year in more than 28,000 square kilometers of the Kenyan land. And it's something that we realize that we can actually tap this solar in other ways other than the ones that we conventionally know. So we have come to look for something that can actually tap into the intermittency of the solar that we actually witness in the solar panels. In Kenya, we were looking at various regions, and we looked at a region like Turkana, we looked at a region like Tana River, we looked at a region like Magadi, whereby there are large tracts of land that are mainly unutilized, and the solar radiations of those places are actually viable for generation of electricity using this technology we want to term as solar ponds. And in the coast region, in as much as Tana River is also within the coast region and they have the Tana River, they also face the challenges that most places face, that when you're far from the grid, the power stability in those regions are actually low, and the voltage stability, since the transmission losses and the inefficiencies in the transmission system. Tana River has a direct normal radiation of 4.95 kilowatt hours per meter square per day, and you can find out that some months the value is even much higher. It reaches 6 kilowatt hours per meter square, and we can actually use solar panels to do what diesel plants are doing in the coastal region. For instance, we have to pave that is used to do power stability in the coastal region, and Tana River is not connected entirely to the grid, and very many households, including the regions that are neighboring it, such as Garissa and Lamu, are not actually connected to the grid. And so taking such a project, such a region, will increase the connectivity. And it can even be done as a microgrid level. And also you realize that the irrigation schemes are also available in those regions, and there's some food processing companies within the Tana River County, of which heat that can be harnessed from the solar pumps can be used and dry those seeds and ripening fruits.
Next, we shall look at the solar pond technology and how it works. Some of you may have heard about solar pond technology. A solar pond is simply a mass of water, a mass of shallow water that's between 1 meter to 2.5 meters deep. And it has a large collection area, and it is used as a heat trap. So in a normal pond, if you have water in a glass and the bottom of the glass is a dark surface, heat from the sun through radiation will heat up the water. But because of convection, the heat that is absorbed rises up and is lost to the environment. What a solar pond does is that it traps this heat that is absorbed by the sun, so that it cannot escape through convection. And this is done by adding salt to the lower layer, so that in the lower layer, if you add salt, the water at the lower layers will be denser than water at the upper layers, so that in the end, water that is hot, that at the lower layer cannot rise above the less dense water. And in this way, you have a system that traps heat. Now, this once the solar pond gets to the normal temperature of about 90 degrees, this temperature remains constant even at night, and it can be used to generate electricity. This is an example of a plant in India. It's called the Bhuj solar plant. I hope I'm pronouncing that right. It's in India. It generates around 150 kilowatts of electricity. And this is the process flow diagram of what we plan to do. On the far end, let me use this. On the far end, we have the solar pond. It is made up of three layers: the upper convective layer, the gradient zone, and the storage zone. So the storage zone is where you have the heat, and this is the zone that prevents the heat from escaping, and this is just the upper zone. And then we plan to use internal heat exchanger inside the pond so that we reduce heat loss. A lot of heat loss happens if you move the heat exchanger farther from the pond. And we plan to use isobutane as a working fluid. The temperatures that are achieved by solar ponds are not high enough to use steam directly, so you use a working fluid, and we plan to use isobutane, which has not been used for such a project. And from there, you'll have a superheater to bring the steam to a favorable temperature. And then you have the turbine and the condenser. We also have a bunch of sensors so that we know what you're doing in this project. We have temperature sensors. You need to generate electricity at the favorable temperatures. We also have Jackson turbidity sensors. They are used to measure the light radiation inside the water, the light penetration, because that is what gives you how much energy you can effectively generate. And then we also have valves to control the flow of everything.
So the next is just a 3D model of the solar pond. We tried to make a 3D presentation so that it can have an eye feeling for the audience. So the next these are some of the applications of the solar pond. So for our project, we tried to size 1 hectare solar pond, which can produce up to about 500 kilowatts. We did a cost projection for our project, and it was coming to about 4 to 5 million, which can be paid back in 3 to 4 years. We in that project, we only considered selling electricity to the utility companies or to the nearby households. But solar ponds can also be used in dairy farms for pasteurization of milk, for grain drying, fruit ripening. As you saw from our first slides, our project, we based it in Tana River. And Tana River, we have water irrigation scheme, so where there are fruits, and there's also maize being grown as the main crop. So when you use solar ponds to ripen fruits, it will save us the chemicals that some of our fellow Kenyans use to ripen their fruits. Then we also can use this for desalination. As you know, the coastal region and Tana River area have a problem of water. Then we also did a comparison of solar pond technology with the other technologies. So you can see that the advantage of solar pond, it has direct thermal storage of heat as compared to CSP and PV. These ones you have to convert the energy into a different form so that you can store it. But for the solar pond, it's directly stored as thermal energy, as heat. Then you can see that solar ponds produce AC power, which can be directly integrated into the grid. As you know, for the PV, you will have to involve an inverter, and inverters are not that cheap. Thirdly, it eliminates intermittency. Then our last point, we talked about that a solar pond, as opposed to producing only electricity like the PV and CSP, you can also get heat and water. And from this solar ponds, heat is very economical. It's one of the most efficient methods of harnessing heat from sunshine. Yeah, that's all for us. So we welcome questions.